Giants of the solar system. Jupiter, a huge ball of gas surrounding a tiny solid core, the colossus of the solar system and its many moons. And the celestial classic Saturn. Pristine television images of the planet's beguiling rings seen from the twin Voyager spacecraft. All in Encyclopedia Galactica. Jupiter is fifth planet from the Sun and first of the outer giants. A mini solar system with 4 huge moons, all visible from Earth in a small telescope. Jupiter, a gigantic ball of gas, largest of all the planets, this view from the Hubble Space Telescope. And this from the famous Voyager explorers, time-lapse, cleaned and enhanced by computer. The portrait of a colossus, turning on its axis in less than 10 hours and big enough to consume Earth 1,300 times. It was Voyager, the most successful craft in the history of spaceflight, that unveiled the great planet. In 1977, the Americans launched 2 Voyager probes for a swing past Jupiter. 2 years later, the planet filled their sights, an awesome sphere where 1,000 electric storms flashed in the clouds below. Massive belts of weather, the like of which had never been seen. Tempests and turbulence. An immense hole in the cloud deck. And the red spot of Jupiter, first observed 300 years ago, confirmed by Voyager as a storm 3 times the size of Earth. This time-lapse is from pictures radioed to Earth as Voyager closed with the planet. 2 Jovian moons and their shadows. At its center, there may be a tiny core set in pressured ice, but for the rest, Jupiter is gas, hydrogen, methane, and ammonia. And because it's so fluid, there's no history to study, no craters, no volcanoes. Had Jupiter been 10 times the size, it would have been a star, but its nuclear furnace never got started. Even so, energy released by its slowly shrinking core means Jupiter radiates more heat than it receives. This Voyager sequence shows the weather bands, circulating at different speeds and opposite directions. The red spot is an anticyclone, a monstrous area of high pressure. But how did it form? A weather band, simulated on computer, demonstrates how several storms, chasing one another around the planet, can eventually merge into a single system, a storm the size of the red spot. On the left, Jupiter as we see it. To the right, an infrared image. It shows temperature variation. Hot gas, driven up from the interior, is red. Colder gas, going down, is white and pale blue. Space Telescope photographed this intriguing feature, an aurora circling the North Pole. It matches the halo of the aurora borealis over Earth, an interaction of the solar wind with the atmosphere. The Jovian aurora was visible evidence of the planet's vast magnetosphere. It's this magnetic field which deflects the solar wind, charged particles continuously streaming from the sun. Jupiter's magnetosphere is the biggest entity in the solar system, larger than the sun, a fact verified by the European probe Ulysses. But for Ulysses, Jupiter was a sideshow. The craft was using the Jovian gravity as an accelerator, a slingshot to escape the orbital plane of the planets. Its mission was to take measurements over the poles of the sun. This is how Jupiter might appear from its moon, Ganymede. The rings were detected by Voyager, fine lunar debris, like talcum powder. Jupiter has 16 known moons, the tiniest discovered by Voyager, the biggest by the astronomer Galileo in 1610. Voyager's pictures of Ganymede catalogue the biggest moon in the solar system, bigger even than Mercury or Pluto. Were Jupiter a star, this would be a planet, but rather warmer. At -200 Celsius, the surface is an icy crust 100 kilometers thick. Wrinkles and craters, an old and unchanged topography. Beneath the crust, a mantle of slushy water riding on a rocky core. Callisto, and the roughest surface of the Jovian moons. Impact craters everywhere. The main feature, Valhalla, a basin 2,000 kilometers across, the biggest of Callisto's craters, here in artist's impression. Otherwise, in size, composition, and temperature, Callisto is Ganymede's double, a planet-sized moon. But why this dearth of geological activity? One reason may be Callisto's greater distance from the tidal effects of Jupiter. Under less gravitational stress, the frozen crust has been unchanged by cracks, folds, or volcanoes. Voyager's next encounter was quite different. The moon is Europa. The surface like finely cracked eggshell. Smooth and uncratered, the whole globe is thought to be an ocean thinly covered by ice. If there's life to be found in the solar system, it'll be in the seas of this moon. Io, innermost of the big four moons, had a surprise. Volcanic plumes first pictured by Voyager 1. There they were, plus the supporting evidence of a sulphurous landscape. In a lake of liquid sulfur, a white sulfur berg. The globe was photographed in more detail by Voyager 2. Here was the most active volcanic body in the solar system. A colorful surface pulsing in the opposing gravitational pulls of Jupiter and Europa. A crust of solid sulfur 20 kilometers deep, floating on a sulfurous sea, and myriad black volcanoes. Other than Earth, Io has the only volcano seen in eruption. This flying pizza will be viewed again. The American explorer Galileo passes Io in the mid-1990s. But Galileo will be fishing in deeper waters. A probe will be dropped kamikaze into the Jovian clouds, there to retrieve data before it's crushed and lost forever in the maelstrom of our greatest planet. Stay with us after the break as we bring you pictures of Saturn, the serene globe, her rings and moons. The celestial classic in Encyclopedia Galactica.
Touch it, and you're tempted.
The world, the people, the machines that make the future world, the real world, fantastic, reality, the future, the present, the future, the present, ingenuity, the people, science in the real world, on Discovery every week. Equinox, Thursdays at 9, Sundays at 6. The whale. Its existence has been threatened by man since the 10th century, yet it has survived with grace and dignity to become one of our planet's most watched and mysterious mammals. Discovery is dedicating a week to the in-depth exploration into the whale's world, from subsistence fishing in Indonesia to the tourist industry off California.
Richard, you touched them! Anybody get that on film?
Whale Watch starts on the 10th of May on Discovery.
Of all the planets, Saturn is the most beautiful. In size, second only to Jupiter, compared to Earth, a monolith. Saturn's diameter is 120,000 kilometers. But like Jupiter, Saturn is an orb of gas. Were there a container big enough, the planet would float in water. Saturn's only solid features are perhaps a tiny central core and the rings. The rings are moonlets, billions upon billions of them. Lumps of icy rock, the size of motor cars. By naked eye, Saturn is the farthest visible planet. By telescope, it has rings and moons. This picture is from a powerful telescope on Earth. And this from Space Telescope. They reveal a Saturnian storm. In time-lapse, again from Space Telescope, the storm girdles the equatorial belt. Just why is a mystery. The cause could be seasonal, for the storm blows up every 30 years, the time it takes Saturn to orbit the Sun. En route from Jupiter, most information about Saturn was gleaned by the twin Voyager probes. Their show began in the early 80s. First, the great moon Titan. The photos were a letdown. Titan was shrouded in haze, but Voyager had sniffed the familiar. With Saturn barely visible through the clouds, this picture is drawn from Voyager's data. An atmosphere rich in nitrogen, like Earth's, but denser, and drizzling ethane. lakes, even seas, a planet-sized moon bigger than Mercury. Titan could be Earth in deep freeze. As Voyager radioed home, one thing was clear. Titan, largest of the Saturnian moons, must be revisited by radar mapper. Meanwhile, a course correction for Saturn. These are real pictures, Saturn, its rings and its moons. Saturn's composition is like Jupiter's, a tiny dense core surrounded by gas, 90% hydrogen, the rest helium. Apart from the rings, Saturn's greatest difference to Jupiter is the apparent lack of weather, obscured by smog. But change the camera filters, and there are the same frantic weather bands. Voyager's task was to scrutinize the upper atmosphere. Once identified, the craft would track a weather feature. But why, compared to Jupiter, the smooth outer haze? The answer could lie in Saturn's cooler temperatures and weaker gravity. In wide shot, the weather belts are just discernible, plus 3 of Saturn's moons. The belts are streams of cloud, mostly blowing east around the planet. Westerlies are rarer. A white spot, just apparent at the top right, is a storm the size of Europe. Through a false color filter, another storm is obvious, the dark spot below the yellow band. This Voyager close-up has the storm with a pair of smaller turbulences. And here a jet stream, similar to the gales that whip around the upper atmosphere of Earth. The difference on Saturn is that they blow at 1,500 kilometers an hour, much faster than on Jupiter. So the tranquility of Saturn's outer smog belies an atmosphere of swirling eddies and churning currents. Voyager beheld a cold soup, the cloud top temperature minus 130 Celsius. To the moon Enceladus, discovered by William Herschel in 1789, scanned by Voyager 2 in 1981, now explored by computer. Enceladus was a mere 500 kilometers in diameter, 60% ice, 40% rock. A young surface. The result, possibly, of interior water welling through fissures and freezing. Another rocky snowball, Mimas, less than 400 kilometers across, with a crater the size of Mount Everest. As this Voyager picture shows, had the missile which caused the crater been slightly bigger, Mimas would have been smashed to pieces. Unluckier impacts, it surmised, created the rings of Saturn, ancient moons pulverized in cosmic collisions. The rings, lunar debris. Using a background star as reference, Voyager was detailed to survey the rings. They stretched for 279,000 kilometers. But the rings were little more than a kilometer thick, and there were thousands of them. This time-lapse revealed dark spokes. One theory is that they're dust levitated above the rings by Saturn's magnetic field. Voyager's pictures ended centuries of speculation. Galileo had spotted something in 1610, but the rings weren't identified as such until 1659 by the Dutch astronomer Huygens. Until Voyager, it was still believed there were no more than 6 or 7 rings. In fact, there are 7 main bands, each comprising hundreds of rings. Voyager not only proved the rings weren't solid, it identified their nature. They're formed from billions of particles, aggregations of silica rock, iron oxide, and ice. This edge-on sequence beautifully records the gaps between the main bands of rings. The particles in the rings range from specks of dust to rocks the size of cars. They're kept neatly in orbit by little shepherd moons. Saturn's rings remain only partly understood, as does the planet itself. The Saturnian day is 10¼ hours, and at 1,500 million kilometers, Saturn is the 6th planet from the Sun, now just a distant beacon. There's no shortage of moons. Iapetus, a frozen rock. Dione, amply cratered. And at least 20 more. Saturn, a celestial classic. Next time in Encyclopedia Galactica, more Voyager pictures of the outer planets. Uranus and Neptune in the cold, dark outer reaches of the solar system. Plus a glimpse of Pluto, a mission for the future. And the wild cards of the planetary pack, the comets, meteors, and asteroids, relics of the formation of the solar system. Next time in Encyclopedia Galactica.